So, hello and good afternoon or good morning or wherever you are in the world. Welcome at a new online seminar from Softing IT Networks. This day, it's my pleasure to hold this seminar. My name is Konstantin Hüdepohl. I'm product manager at Softing IT Networks. And I have a colleague with me today who will introduce himself.
Yeah, hello. Well, welcome from my side too. Yeah, we are both product managers for the IT networks testers, and today we have the active networks now in the webinar. And when you join our webinars, often you know we have a control panel on your screen. There is a possibility for some questions. You can send some questions in between of the webinar, and we will answer you directly or after the webinar together. And we have also handouts attached. You can download this now when you needed the presentations and some marketing material. So I wish you a good time with Konstantin and see you later.
Thank you, Alex. All right, so the topic of today is Ethernet and Ethernet for beginners. So we'll start pretty much at the basics. Can you switch? Yes, thank you. Thank you. So we start at the very basics, but go into quite a bit of details during that presentation. I'll tell you a little bit about softing. Then we talk a little bit about infrastructure elements. Then important terms of and functions in Ethernet networks. We talk a bit about test methods, how you can test Ethernet networks, what can you test in Ethernet networks. And then we also talk about commissioning and troubleshooting networks and have some examples for that. So let's go into the details. So about softing, well, we are a German company. Headquarters are in close by Munich in Haar. We were founded in 1979 with today about 91 million euros turnover. Worldwide, we have some around 400 and a few employees in locations all over the globe. We are in Europe, we are in Germany, Austria, Italy, France, Romania. Worldwide, we are in USA, Singapore, Japan, China, and India. So we have quite a good coverage, I would say. We are 3 business units. The automotive team is looking at diagnosis in vehicles, basically. The industrial team is looking at devices and software for industrial automation. And us as IT networks, the 3rd business unit, we look after test equipment for cables, cabling, infrastructure cabling, copper and fiber, as well as Ethernet networks, copper, fiber, Wi-Fi, Ethernet networks. So measuring devices, what kind of measuring devices do we actually have? We have, if you start top down, we have the certifiers. That's like the top class certifiers for copper and fiber cabling, qualification testers that qualify if an Ethernet is capable of a certain bandwidth, like 1 gigabit or up to 10 gigabit on copper and fiber. A lot of different verifiers to test networks, just the cable of networks, and of course the Wi-Fi network sniffers that are special test equipment for Wi-Fi networks. A very new equipment in this line is our Link Expert series here. Small handheld testers for copper, fiber, and Wi-Fi networks that both test cabling as well as Ethernet tests. And a very new member, which we'll show very soon on exhibitions as well, is our small little Cable Master 210, a very small handheld verifier, basically. So this is about our product line. And now let's take a look at Ethernet. And let's start at the very beginning. What do you need? What's really required for communication? So if you need communication between nodes or devices that want to talk with each other or exchange files, you need a connection media. You need either wide area network, metro area network, or local area network, and you need a cable or another media like copper, fiber cables, or radio Wi-Fi connections, basically. And you need rules for communication, fixed rules. So you need a communication system, like some of you maybe have heard the ISO OC layer model. We talk about that in a bit. And you need a sort of language, which is in our world today a network protocol such as Ethernet. So when you have an increasing number of participants, you need a system. If you only have 2 participants, you can connect them directly with a cable or with a Wi-Fi connection, basically. If you have more than 2 participants, you need a structure. So you need preferably a structured cabling system, and you need a central IT connection system or a connection elements like switches or routers that connect devices to each other and distribute traffic to the different devices. So in a network, you have terminals. Terminals can be printers, PCs, laptops, any device, basically. And in older systems, sometimes you still, this is grayed out here, you still see hubs. Hubs are not used anymore or shouldn't be used anymore because they work like a watering can. They distribute all the traffic to all the devices, which is a lot, which creates a lot of overlapping traffic and overload of traffic, basically. Nowadays, what you use are switches. Switches are intelligent distribution devices that distribute traffic to only those members in the network that need to communicate to each other. In this little example here, if the PC wants to print something, the information to print something is not distributed to all the members in this network, but only between the PC and the printer. So the switch is very intelligent, remembering which devices are connected to which port and to which outlet, basically. So if other devices in a network, for example, network attached storage devices, which are like intelligent hard disks that have a LAN connection that can be directly connected to the network, access points or that can connect Wi-Fi devices, for example, and also servers. Servers, and you have to be careful with the word server. When you think about servers, you always think about the metal boxes, a real server, a real hardware, but a server can also be software today. So a lot of services that run in a network actually are software servers that run as software or as virtual machines in a network. So now we have talked about devices that are in a network, and the devices I shown are only examples. So how do you get now into the internet? Access to the internet is done by the router. The router works like a translator or an intermediate device between the communication in the local area network and in the wide area network. And the router also translates between protocols, for example, between the LAN Ethernet protocol and the DSL, for example, protocol in the wide area network, DSL or ADSL or whatever is used in the wide area network. So the router sits there in between. Then additionally, there's typically another device here called the firewall. The firewall is a gatekeeper that monitors traffic and blocks unwanted or potentially dangerous traffic. So the purpose of the firewall is to keep your internal local area network safe, basically. So you often hear the term gateways. Gateways can occur actually in every layer of a network, and in every layer of the transmission model, basically. I'll talk about that a little bit later. Sorry, the screenshot is in German. My computer is a German computer, so I can't get that in that screenshot in English. But anyway, you recognize hopefully the word gateway somewhere. Gateway can be a router or a proxy server, or that can connect two networks to each other. In this case, in a normal case, basically, your local area network to the internet, basically. Or in larger networks, gateways can also connect parts of networks together in a local area network. The default gateway or standard gateway typically is the connection to the to the outside world. Usually that's your router or proxy server. In a home network, that's the small router box you use at home, basically. So proxy servers, you've heard already the word proxy server. What is actually a proxy server? Proxy servers are computers or virtual machines that can connect different parts of networks to each other and can control the traffic between these parts of the network. So for example, it can connect you to the outside world, or it can only connect you to another section of your LAN network. In larger organizations, proxy servers are used to monitor traffic between sections of the network and guide traffic through different sections of a network. So if you look at home networks, what we've learned now, what we call in a home network, the router, the little box that sits at your telephone outlet, basically, actually is much more than a router. It contains the router, the firewall, and a switch, and actually also an access point in many cases. So it's actually a multifunctional device in your home network. In Germany, a very popular example is the AVM, Fritzbox is a very popular example in Germany. There are also quite a few more devices combined in that router that we'll learn about in a few minutes. So before we go more into the other devices or other terms, let's talk a little bit about connection speed and auto negotiation. That is something in nowadays works like automatically. You don't think about it. You just plug in and it works, right? In legacy networks, auto negotiation and speed can cause issues, and you need to think about when you are connecting an old device or when you connect to an older network. You can connect with a fixed speed or with an automatic negotiation of this speed. So when you set a router to a fixed speed, you have to be careful that the end device you want to connect to is set to the same speed. So if I want to connect my PC to the switch with 1000 megabit per second, either they run on auto negotiation, then they automatically connect to each other, or when the switch is set to a fixed speed, or when the PC is set to fixed speed, the other device also needs to be set to that speed, otherwise they don't connect. And in older networks, older speeds, you sometimes see half duplex or full duplex. For example, 100 megabit half duplex, or full FD for full duplex. Same thing there. If the speed is set to 100 megabit half duplex, you need to set your end device, like the PC or the surveillance camera or whatever, also to 100 megabit half duplex, or they will not connect to each other. So from 1 gigabit upwards, it's always full duplex and auto negotiation. So you don't need to care about that anymore, luckily, because in older networks that created a lot of issues. If you now, just coming back to that example, be careful with that. If you have a 100 megabit half duplex computer and you want to connect that to a switch with 1 gigabit auto-neg, they will not connect to each other. So be careful with older devices or older networks. So let's look a little bit more about important terms. MAC addresses and IP addresses. The MAC address, the media access control address, that's a unique address of the physical interface on your device, on your computer, for example. That's the address of your RJ45 port, for example. This is unique to a device, and you can, in an outside world, you can compare that to a postal address of your house. That will not change. The IP address is the Internet Protocol address. That is an address a device receives in a LAN network. You can compare that with a telephone number. You can change your telephone number in your house, basically. IP addresses can be set automatically, so you receive an address from a device in the network, and we'll come to that, from the DHCP server. What a DHCP server is, we'll talk a little bit in a minute. Or you can set a static IP address. Both cases are useful in some circumstances, but you have to be careful with static IP addresses, and we'll talk about why in a minute. So what's the DHCP server? The DHCP server is Dynamic Host Configuration Protocol Server. This device manages IP addresses in a LAN network. It does a dynamic assignment of IP addresses and other network configurations to devices that are connected to a network. So when I connect my device, like a laptop or PC, that is set to automatic DHCP address. When I connect that to my network, it will ask the network basically, so can I have an IP address, basically? And then the DHCP server says, yes, here I'm the DHCP server. Here's your address and network configuration. Right, so what can go wrong here? What can be problems here? Many IoT devices have integrated DHCP servers. So if you put in an additional DHCP server into your network, you can have problems in the network. More than one DHCP server can then give the PC that you just want to connect to your network false information. So it can happen that you get multiple assignments of the same IP address by different servers. You can have addresses from a misconfigured address range, for example. All kinds of crazy things can happen. If you use more than one DHCP server in a network, this has to be really well planned. And in larger networks, actually, network administrators use more than one DHCP server for security reasons. If the primary DHCP server hangs up or is not available or has a system failure, the secondary DHCP server steps in and manage the IP addresses in the network. That works well if it's well planned. If it's not well planned, it causes havoc. So let's go back a little bit to the dynamic and static IP addresses. End devices such as laptops, workstations, and so on, they typically have a dynamic address. So you just connect and you don't worry about it. You get an address and everything will work, hopefully. The assignment of static IP addresses in a network must be very, very well planned. Otherwise, you get duplicate IP addresses in a network or devices that will not answer and so on. So this can cause really havoc if you don't plan that really very well. It's preferable, or it's actually advisable, that the address range that you use for static IP addresses should be reserved on the DHCP server. For example, the DHCP server only gives addresses, dynamic addresses up to, like, for example, 192.168.0.200, and everything beyond 200 is reserved for static IP addresses. So in this, you see the example here on top. So dynamic addresses up to 200 and static IP addresses above 200, for example. Devices such as file servers, surveillance cameras, access points, or devices that are always in the network, sometimes get static IP addresses assigned by the system administrator. That can have some advantages for the system administration, but again, needs to be very well planned. So, oh, sorry. So when you go, I forgot to mention that. So be careful when you install new devices in a network that if you need to install, set a static IP address to your new device for some reason, you need to discuss that with the system administrator, that the system administrator gives you a reserved address you can use. Don't set a static IP address unless somebody authorizes you to do that, basically. Okay, so much about that. Let's look a bit to public and private IP addresses. What's that now? So a private IP address, a public IP address is the address your organization or your home has in the internet, in the wide area network or metro area network. That is an IP address that is provided by the network provider, and the router of the network needs to be manually configured to actually work with that public IP address. The private IP address is something you can assign by yourself in your network. It is an address that is only used in your network and is only visible in your network. So the LAN IP address, the private IP address of your PC is only visible in your network and cannot be directly reached from the outside world. The translation between private IP address and public IP address basically is done by the router. The router takes your request. For example, you want to look at wikipedia.de or wikipedia.org, and then sends your request to Wikipedia. And then also Wikipedia answers to your router, and then your router gives your PC the information. There are some address ranges that are basically used. The 192 range is for small networks. The 172 range is for media and larger networks, and the 10 range is reserved for very large networks. You can, we don't go into details right now, it's not so important, but that's basically the three address ranges that are typically used. There's another address, the IP address format we need to look at, the IPv4 addresses, like the ones I've showed you above. They consist of these 4 blocks with each 3 digits. And in the subnet mask of these 4 digits, you can define how many segments in the network you can actually see. You see this 2 in the bottom. Let's see if I can show that here. Where are we? Down here, right? You can see here the 255, 255, 2550. The 0 basically means that your device can only see other devices that have the first 3 digits the same, but just the last digit is different. Like from so the subnet mask basically defines how many devices your device can see in a network. And then we have IPv4 and IPv6. IPv6 is a much larger address. The reason for that is in the internet, wide area network, metro area networks, the address range of the IPv4 basically has been used up. There are no more addresses, no more new customers can connect to the internet through their router. So they invented the IPv6 range, which gives you just a much wider address space. So I have to always read that because I can't remember that. So the IPv6 range is 3.4 by times 10 by the potential of 38 addresses. So that will last for many generations probably. It's important also for Internet of Things if you think about how many devices are added in Internet of Things. Anyway, so let's move on. Let's talk about how do we actually find addresses in the internet. So how does my router now know which IP address has wikipedia.org, for example? That is done by the DNS server. DNS servers are in your local area network, a domain name server, and also in the internet, basically. So a DNS server acts like a telephone book. The DNS server knows the station names like media server or my PC, and knows the IP and MAC addresses of these devices. So when my computer, for example, when my computer wants to retrieve a file from the media server, it looks up the DNS server first. So, and providers also maintain their DNS servers. That's like a public telephone book. And that's where my router finds the address, for example, of wikipedia.org. So if my local DNS server doesn't find an address or doesn't know about the address, for example, wikipedia.org, then my local DNS server in my LAN will contact the provider's DNS server and ask the provider's DNS server for the address and learns then this address. So, for example, talked about wikipedia.org. The IP address of wikipedia.org is this 208.80.154. What is it? 224, right? So then my local DNS server knows which IP address actually to use, and then gives my PC the IP address in my router. By the way, a lot of people use the word URL, but many people don't really know what that means. URL is Uniform Resource Locator. It's just another abbreviation. Okay, let's move on. Just again, this example, my little PC wants to retrieve a file from my media server. Then it basically sends out the request. Does anybody know media server? Then the DHCP server says, yeah, I know media server. It has this address. And then my PC can reach the media server and get information from the media server. Cool. So let's move on. Domains. What is a domain? Domain is a coherent part of a hierarchical domain name system. So for example, our domain is the domain softing.com. But how are domains organized and how does that work? The local area domain can be, so the domain in my network locally can be freely chosen. In my example of this router before, the Fritzbox router, the default is fritz.box. That's probably 90% of these routers, the domain name for the local area network is just fritz.box. But in the wide area network, in the internet, domains are controlled by an organization. It's controlled by the NIC, the Network Information Center, and they control and maintain the top level domains. So if an organization needs or wants an internet domain, they have to basically get that from the NIC, or actually the provider will get that from the NIC. So how are domains organized? There's the top level domains, that's .com, .org, .e, .co.uk, and so on. And then the second level domain is the ones where you can have your company name, for example, Softing or .com or Google.com, wikipedia.org. Below that are the third level domains. Come on, here you go. The third level domains that actually can be assigned by the companies by themselves. So for example, itnetworks.softing.com or ftp.softing.com and so on. Station names in networks then the station name is also organized with these domain names. For example, a demo PC in our network would be demopc.itnetworks.softing.com. All right, so let's look at something else. Let's look at the VPNs, VPN virtual private networks, virtual private LANs, sorry. VPNs are encrypted connections through unsecure networks like the internet. So if I want to connect our network in Munich, in our headquarters, to our network in Knoxville, where our subsidiary in Knoxville sits, we use a VPN to connect both to each other. The VPN between two local networks is configured in the routers of these networks, basically. So they manage a encrypted connection, and for users, it looks like a local area network. So I can see from Munich my local area IP network addresses from my colleagues in Knoxville, for example. If you connect a device that is, for example, in your home, you can also run a VPN to your local area network, and for that you need special software that allows you to connect to your local area network. VLANs. So what's the difference between VPNs and VLANs? VLANs are virtual LANs. VLANs run in the same local area network, and they basically are used to separate local area networks that are physically on the same network, physically on the same switch. So all devices are on the same switch, but you want to separate them somehow. So what you do is you use the VLAN technology to basically put the two segments or more segments aside. VLAN 0 is always by default on, so the VLAN, all the devices by default are on VLAN virtual LAN 0. But if I, for example, want to have now two virtual LANs to separate these blocks of devices, I would, for example, use virtual LAN 1 and virtual LAN 2. The example here is if you, for example, want to use virtual LAN for the finance group and virtual LAN 2 for the production group. The production guys shouldn't see the bookkeeping department files, and the bookkeeping guys shouldn't mess with production processes, basically. So it's nice. It's a very useful tool because you have one physical network, one switch, one cabling, and so on. But logically, you have separated those two. So virtual LANs unfortunately have two different versions: tagged and untagged VLANs. Tagged VLANs. In tagged VLANs, every package has every Ethernet package has a VLAN tag. So devices like our Link Expert or Net Expert or other devices on the market that work on troubleshooting Ethernet networks or diagnose Ethernet networks, they can recognize those VLAN tags and say, okay, there are VLANs 1, VLANs 2, and VLANs 3 or whatever in network present. And there's also untagged VLANs. Untagged VLANs basically are configured in the switch, and the switch knows that port 1 and 2 are in VLAN 1 and port 3 and 4, for example, are in VLAN 2. It's not possible to recognize untagged Ethernet packages because they have no identifier that they are in a VLAN. So devices that look at networks and look at virtual LANs, they can only recognize tagged VLANs, but not untagged VLANs. Untagged VLANs you can only see when you look on the configuration of the switch, basically. So looking back in our network, our router is now pretty stuffed with things. It has a router, a firewall, a switch, an access point, the default gateway, the DHCP server. It can run VPNs and can run DNS servers. So it's a pretty powerful device, this little box. Let's go back a little bit and look at structured cabling in Ethernet. When we think about Ethernet, we think about typically, office buildings. You have large Ethernet cablings, large Ethernet networks. We think about data centers. We think about homes, like single-family homes or multi-tenant homes. We think about special buildings like hospitals or banks that use Ethernet. And we think about automation now, Internet of Things, industrial Internet of Things. Automation is a big topic. But there are also things like windmills. Windmills use Ethernet cabling and Ethernet to communicate. Cranes use Ethernet for sensors. For example, the video cameras on cranes and the contact sensors on cranes, they use gigabit Ethernet for communication. Intelligent farming is a big topic nowadays, that actually Ethernet and sensors and Internet of Things basically goes into farming and is used in farming. Ships and big trains, they are like rolling data centers. This train you see here on the top is a German ICE train. This train has about 700 or 800 data connections, data links, and that run basically with Ethernet. A ship like a aircraft carrier here, or a cruise ship, they have thousands of Ethernet connections. So they are actually really swimming data centers, if you will. So today, when we look at testing cables and testing Ethernet, we don't only need to think about the classical things like the homes and data centers and office buildings. There's many more applications where Ethernet is used and drives the need of testers for many different applications. So keep your eye open on Internet of Things applications and new Ethernet applications. So modern networks, many different services. When we talk about what's going on in a network, we have phone, we have Wi-Fi, we have intelligent lighting with PoE, smart TVs, manufacturing automation, file servers, media servers, surveillance, security, access control, pressure pressure detection, presence detection, workstations, laptops, data centers. Building automation is a big thing, intelligent heating, air condition, shutters, lawn mowers, sprinklers, etc. My lawnmower at home, for example, is called Sean. He has an internet address, he has internet access, looks at the weather, if the weather is good, and if he can go out and cut the grass. If the knives of the lawnmower are worn out, he sends me an email that he wants to have the knives changed. So that's just one example. And of course, the connection to the campus Ethernet, the connection to the internet, and in all that, don't forget that this is all Ethernet devices, or many of these are Ethernet devices today, and they are somehow connected with Ethernet cabling. Even your Wi-Fi is connected with an Ethernet cabling. The Wi-Fi access point is connected with Ethernet cabling. So many different services, many different problems. Modern networks have a lot of different problems. Either devices may not be reachable or cannot connect due to cabling issues. Many issues are actually cabling issues. Ethernet and incompatibilities, speed incompatibilities, PoE, power over Ethernet issues, switch port misconfigurations, device IP misconfigurations, rogue devices, so unallowed devices in a network, misconfigured other devices, access rights, security issues, virtual LAN issues, Wi-Fi issues. You see, many different things can go wrong in a modern network. And the more devices you have in a network, the more things can go wrong. Just if you come back at your home network, how many devices do you have in your home network? That's of one of my colleagues here. He has 39, I think, devices in his network, home network. So you see, it's crazy how many devices are in just even in small networks today. How do you find out how many devices are in a network? Well, you can do that with your PC, of course, but handheld devices, handheld testers can give you a very nice list of the devices in a network, the MAC addresses, IP addresses, DNS names, and so on and so forth. That's just a screenshot of one of our devices for the NetExpert XG2, for example. So let's have a short look on communication in the network, the reference models. That's important because we need to understand a little bit how communication works. It basically works in 7 layers: the physical layer, data backup layer, network layer, transport layer, session layer, the representation layer, and the application layers. You can connect that with, compare that with phone systems. Like the phone is connected, then you get a buzzer, then you get a connection setup. You have speech rules that don't cut into other speeches. You have mediation, language selection, and the topic of your conversation basically is analog to what you would see on when you use analog phones. But so the physical layer is really where you transmit bits, right? This is where the bits run on your cable. The data backup layer is the switching layer, the layer 2. This is where communication in your local area network happens. Layer 3 is the router level. Layer 3 switches are routers. They can communicate on the TCP/IP level. And above that is software, basically. So how does communication really work in these layer model? Look at the little guy here on the top, sitting here on the top, this guy here. He wants to talk to the other guy on the right hand side of the model, and sitting over here, right? He wants to talk with the guy over there. He actually says, hey, can you send me this picture? So how does he send this request? In a local area network, this goes down through all the communication layer protocol, goes on the physical cable as bits on the physical cable, goes on the layer 2 switching on your switch, goes back to the physical cable, and then your guy on the top right receives that request. Can I have this? And this is all LAN. Can I have this email with this image? Then the guy basically sends the image. How does that work in a wide area network, in the internet? Basically, same thing. Can I have this email with this image, please? Goes through the layers, but in this case, it does not only go through the switching layer 2, but goes through switching layer 3. So goes through switching layer 3, goes through the internet somewhere, from Munich to Knoxville, for example, goes into the switch in Knoxville. Layer 3 switch in Knoxville goes through the local area network cable to the guy here. So this is first it's LAN, then it goes through the wide area network, and then it's LAN again, basically. So the guy gets this request, can I have this image, and then he can basically send the image of the plane to the other guy. Just one example how the communication model works. This is really a crash course on ISO level, so we don't go through all the details here. Just for your understanding. Let's talk a little bit about test methods. What can I test in a network? You can verify things. So in a verifier, you test the basic wiring of a cable. So for example, with a little tester like that, the link cable master 210, you would just see if the wire of the cables you want to test are correct. A little bit more sophisticated testers, they give you a color screen here like this one, also with length, for example. So you get a length information. That can be very useful if you have a damaged cable, because then you will find the distance to the damage basically. Verifiers also can, for example, some of the verifiers can give you the image of a video microscope to inspect end faces of fiber optic connectors if they are clean. If a fiber optic connector is not clean, the connection might not work. Qualifiers is the next step of testing. Qualifiers, basically, they test if Ethernet works full speed on a link. So for example, can I really transmit 1 gigabit, or can I really transmit 10 gigabit of data full speed through a network? They basically build up a network connection between both ends of this link, and they basically run full speed Ethernet and check the bit error rate and several more parameters and determine if a cable or a link is actually really able to transmit that traffic. The highest class is the certifiers. Certifiers test the physical transmission properties. They test return loss, crosstalk, insertion loss, and many more parameters, and determine if these parameters are conforming to cabling standards. The cabling standards typically don't know about the Ethernet speed, but they determine if a cabling conforms to a cabling standard. And then we have testers or methods to do active troubleshooting. So these devices, they can connect to Ethernet. They can find out how many participants are in a network, like in the screenshot you saw before. They can run diagnosis tests like PoE tests and many more other tests in a network to determine if you have connection problems to the network. So when you do commissioning and troubleshooting, those testers are most useful for a network, because for a network user, basically, because with those testers you can find out if your network has a connection issue on some level. So first of all, you can do the cabling test, qualify, certify, verify, find out if the cabling is good or if you have cabling issues, and then also on wireless LAN test test certain things like field strengths, channels, encryption methods, and all that. And then when setting up a network and configuring a network and troubleshooting Ethernet problems on all the media, copper, fiber, Wi-Fi, you can run diagnosis on the network, find, for example, power over Ethernet issues, list network devices, and run, as I said, several IP tests on that network. So when you go and, for example, one example is I want to connect a new device to my network, like I want to connect this surveillance camera to the network, and the surveillance camera doesn't connect. So what you're gonna do now? It doesn't connect. First of all, you can of course look at the switch and look at the configuration of the switch. All the modern managed switches, they have very nice web pages where you can look at the switch configuration. That works well if you have access to that switch and if the switch has a configuration problem. But the switch doesn't know that there is a device connecting if the device isn't connected, right? If the surveillance camera does not connect, the switch will not help you because the switch doesn't see that device. So this is only partly of use. And in many customer networks, you don't anyway have access to the switch. So the only thing you can do is put a handheld device onto that link and try and find out what's wrong with that link. In this case, I've connected one of my link experts to the network, and I'm running a test now on that network. And actually, I find out in this test that PoE class 6 doesn't work. And well, the IP camera was set to use PoE class 6. So I can either now enable PoE class 6 on the switch, or I can reduce the PoE class on my device. So I can set my device to PoE class 4. So then with the handheld tester, I found the source of the problem. And then I can remove my handheld tester and connect the IP camera with PoE class 4, for example, and the camera will work. Just one example. So network test functions. What actually can you test in a network with a handheld tester? You can get information on the link status, like connection setup, speed, DHCP, all these things. You can run network detection. You can see devices in a network, so you can see how many devices are in the network, how are they configured. You can run traceroute to nodes outside of your network or inside of your network. For example, you can run a traceroute to google.com and find out if you can at all access the internet. You can run LLDP and CDP tests. CDP and LLDP are discovery protocols. LLDP says link layer discovery protocol. CDP is Cisco discovery protocol. Modern switches, they send out regularly broadcasts to every port with the configuration of every port. So our handheld testers can intercept that configuration messages and tell the user at which port you are connected to and at which switch we are connected to. Our testers can find out duplicate IP addresses. Remember, if you misconfigure your network or your device, you can end up with duplicate IP addresses in your network, which is very dangerous for a network. Our testers find duplicate IP addresses and warn the user about the duplicate IP addresses. You can use the microscope as shown before to diagnose fiber optic connectors if they have issues. And of course, you can do various scans on wireless LAN to run a wireless diagnosis on your network. For example, just look at the different link speeds that are available in a network. The tester gives you a list of the available link speeds, what you can connect to. That's an information on DHCP. You get all the DHCP information of the server, your IP address, the subnet mask, the DNS server in your network, the lease times, how long is this IP address valid, basically, the address of the DHCP server, and the response time of the DHCP server. Shown already the list of the network devices in a network, and the red bar you see there on the bottom of the screen here, on the bottom here, screenshot here, actually is a duplicate IP address. So the tester in this network found a duplicate IP address, which is, as I said, really dangerous in a network. Of course, the testers then give you PDF reports on that, so you can report what you have found and give the report to your end customer, for example. Other test functions like ping, and traceroute and so on are very useful to diagnose if you can reach devices in a network. This is a traceroute to, for example, a IP address. Here you can see all the nodes that have passed between your device and the network, the end address, like, for example, Wikipedia or Google. And you can, we've talked about LLDP and CDP before. These are examples about what you can get as information with the LLDP report. you can get all the information on your switch port, basically. So very useful information for diagnosis of your network. You can detect virtual LANs if they are tagged virtual LANs. Remember, untagged are not possible to detect in a network. So we can detect virtual networks in a LAN if they are in use. So you see packets that are actually in use for virtual LANs that are in use. And basically that gave you a quite nice overview on the possibilities you have with a tester. So a lot of people we see on exhibitions, they first say, oh, I use a PC, that's actually enough. I can see whatever I need to see with a PC. Yeah, but when you then talk about what can you actually see in a network, people don't actually realize what the benefits you get from a handheld device. So let's look at the benefits compared of a handheld device against a laptop for a moment. First is portability. Yeah, I mean, nowadays laptops are small. You can run around with a laptop, but having this in your pocket is just so much more convenient, right? So portability is okay on a laptop, but on a handheld much better. Ethernet tests, yeah, all of them can do Ethernet tests, and on a laptop they are actually maybe even better because you have a larger screen. But support of video scope is also something you can use on your laptop with adapters and so on. But you know, running with your laptop and a video probe is already not so handy anymore. Physical media test. Your laptop cannot run a wiremap test. So if the cable is broken, your laptop cannot find that. It cannot diagnose a fiber optic connector, for example, a fiber optic link, for example. PoE tests. Your laptop doesn't know about PoE. So whenever you have a PoE problem, laptops are no use for that. So that's only usable on a handheld device. Port for fiber optic tests. So handheld laptops usually don't have a port for fiber optic tests. So that's also only something you get on a handheld. You can put an SFP port in your handheld, basically. 10 gigabit Ethernet. On a laptop, maybe not. So our handhelds, they recognize 10 gigabit or work with 10 gigabit. Like the XG2 can do the qualification test, run 10 gigabit full speed on Ethernet. Security. A laptop is vulnerable to viruses. So you in many larger organizations, you're not allowed to take your own laptop for diagnosis into that company. So when you need to do Ethernet diagnosis here, for example, at Softing, we do not allow foreign laptops in our network. Usage allowed at customer side. Well, as I said, it depends on the customer. Many customers don't allow laptops or PCs in networks. So handhelds, they are secure against viruses. They have a secure boot system where viruses can't touch that system. So they are generally accepted in a network. Some larger customers don't allow wireless devices in your network. That's why, for example, on the Link Expert, we use a wireless USB stick. When you remove it, it doesn't have wireless, so you can access the customer's network. So looking at the troubleshooting again, you know, when you look at the full range, most useful are actually the verification qualification testers for troubleshooting and commissioning Ethernet networks. That's the short presentation I had today. We are running almost out of time now. I would like to point your also to our other online seminars. This is actually the last live one we do in this series, but we're going to do more series later on. We have a lot of recorded seminars on our website. So if you have time, take a look at itnetworks.softing.com and find out what other useful seminars we might have for you. With that, I would like to thank you for your patience and for your audience. It was, I hope you could take some good information with you. Would like to call my colleague Alex back on stage, and let me check if we have had any questions.
Not directly any questions, but thank you again for the technical details of the new Link Expert series, the functionalities. There was a lot of interest on it, I think. The last chance is now to upload or download the handouts at the moment before we close our session now. Thank you very much also to all attendees on this webinars. This is really the useful. Lot of your was all on our seminars available. It was really nice. And yeah, all of these webinars and seminars are recorded, and you can see that later, what Konstantin said before. Thank you very much.
Yes, thank you very much, and stay tuned. We'll come back with a new series not too far in the future, and hope you enjoyed it, and let us know if you have any questions. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.